Okay, so in this first example, we have the terminal side of an angle theta. We don't know theta. In these problems, we will never know theta. In standard position passes through the point 12, 5. So here's the point 12, 5 drawn. Find the values of the 6 trigonometric functions of angle theta. So here's what we're going to be doing. So we're going to be finding all 6 of these trigonometric functions. Okay, so let me get my pen tool ready. We get sine of theta is equal to y over r. I'm going to go ahead and write that out, which is equal to, this is our y, this is our x, and this is our r. So y over r, 5 over 13. That's a 5. Okay, so do the same thing with cosine and tangent. Cosine of theta is equal to, let's see, x over r. So come over here, x is 12, r is 13. And then tangent of theta is equal to x over, or no, y over x, which is equal to 5 over 12. Okay, so now that we have those values, and if you remember, the other 3 trigonometric functions are just the reverse of those, the inverse of those problems, of these solutions here. All right, trigonometry class, this is what we're going to be doing is section 1.3, and this is all about trigonometric functions. We've looked at trigonometric functions before in geometry, sine, cosine, tangent. We're going to be adding a few more of those to the list of trigonometric functions that we'll be looking at. And then we'll also be looking at quadrantal angles again. Okay. First thing about trigonometric functions, we're going to be looking at these functions with our examples of our angles are going to be in standard position in the xy coordinate system. And here we have an angle right here, angle theta. And like you see, it's in standard position. This is going to be our x distance. So from the origin to all right, so our first example, we are asked this right here. We're asked to find the values of all 6 trigonometric functions of angle theta, knowing that our terminal side, this right here, passes through the point 12, 5. So our distance here is 12. This distance for y is 5. And then our r here is 13. So here we have r equals 13. 12 is our x, 5 is our y. And we're going to be using what we know from the previous slide, that sine is equal to y over r. Sine of theta is equal to our y over r. And that is equal to, let's see, 5 over 13. And then cosine of theta is equal to x over r. And then that is equal to, let's see, 12 over 13. Goodness. Okay. And then our tangent of theta is equal to y over x. And that's equal to 5 over 12. Now, if you want your last three trigonometric functions, remember, they're the inverses of sine, cosine, tangent. So the inverse of cosecant can be found from sine. Just flip that around. It's 13 over 5. And then secant, here, draw a line down here. Secant of theta is 13 over 12. And then, I'm sorry guys, this is really bad. There we go. Fill in the blanks. Cotangent, denoted by COT, of theta is 12 over 5. And there we go. All 6 trigonometric functions right there for you. All right, so let's do the same thing with this problem here. In example 2, we have the terminal side of the angle theta in standard position passes through the point 8, negative 6. Find the values of the 6 trigonometric functions of angle theta. So again, we are going to define this 8 as, let me get my pen tool, as our x. This is our y. And this right here is our r. And how we find r is, if your homework problem doesn't have a problem drawn out like this for you already, remember how you find r is by using that formula, that r is equal to the square root of x squared plus y squared. That's supposed to be a 2. Anyway, so what we're going to do is the same thing as we did on the previous one. Sine of theta is equal to y over r, so 6 over 10, and it's going to be a negative 6 over 10. Let's see. And that's going to reduce to negative 3 over 5. And then let's go to our cosine. Our cosine of theta is equal to the x over r, so 8 over 10. And that reduces to 4 over 5. And then tangent. And that's equal to y over x, which is negative 6 over 8. There we go. And again, it reduces to negative 3/4. Goodness, I've got to get a better pen for this thing. Okay, 3/4. Good enough. All right. Now to find the other 3 trig functions, just remember, Cosecant goes with sine. So cosecant theta, negative 5/3 is what that's going to be. Secant goes with cosine, and you're going to end up with 5/4. And then cotangent of theta is equal to negative 4/3. And we're done. All right, so let's look at another problem. All right, very similar to the last one, or the last two that we had, except we have something a little different. We have an equation of a line given to us. And when we have an equation of a line given to us as our terminal side of our angle theta, what we have to do is find two values, or find a point on that line. So find an x and a y value. So just plug in anything for x. So for this right here, what I did was plug in -2 in for x, and you get -3 for y. So those are your two x and y values. So x equals -2, y equals -3. And then you can find your r by plugging it into that formula. And let's see, your r is actually going to end up being the square root of, darn it, 13. And that's not negative square root, that's just a square root symbol. All right, so you got all of your values. Now find your 6 trigonometric functions for this angle right here. So sine of theta is going to be your y over r, so -3 over the square root of 13. Now, whenever you have square root in the denominator, we're not going to keep it in the denominator. We need to rationalize this thing. So if you remember how to rationalize the denominator, you multiply both numerator and denominator by what you have in that denominator, so square root of 13. So we actually end up with, for sine theta, our answer is -3 square root of 13 over 13. And there's our solution for that one. Now let's do cosine. Cosine of theta is our x over r. Again, we're going to have to rationalize this thing. So we're going to have -2 over square root of 13. It's going to end up being very similar to our answer here, except instead of -3, you're going to have a -2. So -2 square root 13 all over 13. And then our tangent of theta, let's go ahead and do it on this side. That's just going to be our -3 over -2, which a negative over a negative becomes positive. So 3 over 2. Now on this next slide, we're going to finish it up. We're going to write the cosecant, secant, and cotangent of each of these. So remember, whenever we're doing the cosecant, secant, and cotangent, if we have any square roots, come back to this answer and do the reciprocal of that answer there. So we don't have to redo the rationalizing the denominator. It's just going to be the negative square root of 13 over 3 is going to be your solution for cosecant of theta. So cosecant, oops, let's use that ink pen tool there. Okay, cosecant of theta. All right, it was the negative square root of 13 over 3. And then our sine, or cosecant, and then secant. Let's see, secant of theta. We're comparing it back to sine. Remember, our sine solution ended up being the negative 2 over the square root of 13. So do the reciprocal of that. You get negative square root of 13 over 2. And then cotangent, we ended up with 3 over 2 as our solution for tangent of theta. So do the reciprocal of that. We get 2 over 3. And we're done finding the solutions to all of those 6 trig functions. All right, so example 4 deals with finding function values of quadrantal angles. So we're going to do this very similar to what we've been doing with the other previous examples. Just like those, we're going to find what our r value is. We have our x and our y. This is our x and this is our y. And our r value is just going to be, let's see, r is equal to, remember, the square root of x squared plus y squared. Y squared is just this. And you end up having r just being the positive 5. All right, so there's our r and our x and our y. And now we're going to find all 6 trig functions. So sine of theta is our y over r, so negative 5 over 5. Which is negative 1. Cosine, x over r, so 0 over r, which is just 0. And then tangent, okay, tangent of theta is our y over x. So actually, this is going to end up being undefined. But let's go ahead and write it out just for fun. This is, I can't write it. I'm undefined, right? Undefined. No answer. Okay, let's find the other 3 trig functions to this terminal side. This is actually 270 degrees, if you didn't notice that. This whole angle is 270 degrees. But that's not what we're looking at right now. We're just looking at this point right here. That is on our terminal side. All right, so sine of theta compares to cosecant theta. And remember, do the inverse of that, or the reciprocal of that, so it's just going to be 5 over negative 5, which is still negative 1. And cosine, I didn't write the answer, what it was previously, but it's 0 over 5, which is still 0. But for our solution to secant of theta, we're going to end up getting 5 over 0, which again is undefined. And then tangent theta, compare that to cotangent theta, and do the reciprocal of that, you get 0 over -5, which is equal to 0. Okay, so there, all of our 6 solutions to our trigonometric functions. One more example. Here we have another quadrantal angle that we're looking at is 360 degrees. Oh, sorry about moving that on you guys. Let me get my pen tool out. There. But here is a point that lies on our terminal side. Our R value, just like the previous one, is going to be the square root of 2 squared, which is just going to be 2. So R is 2. Our X is equal to, again, my pen doesn't want to write, 2, and our Y is equal to 0. So use this right here to figure out all 6 trig functions. Sine theta. I'm going to go through this quickly. Y over 2. So y over r is 0 over 2. That's going to be 0. Cosine. And that is our x over r. So that's 2 over 2, just 1. Tangent is y over x, so 0 over 2, 0. Now do the reciprocals. Cosecant of theta is equal to, and that's going to be r over y, so 2 over 0, that's undefined. And then secant of theta is going to be r, again, r over 2, this time still going to be 1, 2 over 2. Then cotangent. It is going to be undefined, because that's just, let's see, instead of y over x, you have x over y, so you have 2 over 0. Notice in quadrantal angles, if your any of your trig functions end up being 0 as the solution, the inverse trig function, reciprocals, are going to end up being undefined, just like these were. So here's a list, is what I have next, of quadrantal angles and their solutions to all 6 trig functions. Notice all of your solutions are going to either be 0, 1, -1, or undefined. So for 0, here you have all 6 trig functions. 90, again, all 6 trig functions there. 180, 270, 360, went around the whole circle. And notice how all of them have 2 trig functions that are undefined. That's always going to be the case for any quadrantal angle. So that is actually the end of this lesson. Pretty short and sweet. So I will see y'all in class and we'll discover more things about trig functions and hopefully answer questions about things that you may not have understood on this section here. So what I said, I'll see you in class. Goodbye, everybody.